The promise of 5G isn't really about speed, not just speed anyway. The real magic is that 5G isn't just one network. It's a whole collection of virtual networks all running on the exact same hardware. So today, we're going to crack open the cryptographic fortress that makes this all possible, the 5G key hierarchy.
So that's the big question, isn't it? How on earth can a single physical infrastructure support all these wildly different services without them stepping on each other's toes? Or even worse, creating massive security holes between them?
So, picture this. You could have one virtual network, what we call a slice, that's completely dedicated to autonomous vehicles. This slice needs unbelievably low latency and just rock-solid reliability. Lives literally depend on it.
And get this, happening at the exact same time, on the exact same cell tower, you need another slice just for emergency services. This one has to have ultimate priority, and it has to be totally immune to network congestion. It just cannot fail.
And then, of course, you've got a third slice for the millions, maybe billions of Internet of Things devices, like, say, your smart toaster. This slice has to handle a massive number of connections, but the data is tiny, and speed is not a big deal. So, how do you secure all three of these worlds independently?
Well, the answer lies in a completely new way of thinking about security. This isn't just an upgrade, it's a complete redesign from the ground up. And at the very heart of it is the 5G key hierarchy, a new cryptographic blueprint built for this world of virtual networks.
But to really get what makes 5G so special, we first need to take a quick look at where it came from, the 4G security model. It was strong, for sure, but it was designed for a much simpler, one-size-fits-all kind of network.
In the 4G world, security was basically a linear chain of trust, kind of like a ladder. It started with the secret root key on your SIM card, the I. From that, a core network key was created, then an access network key for the cell tower, and finally, the keys that actually protected your data. It worked, and it was effective, but it had absolutely no concept of multiple, independent virtual networks.
Okay, so that brings us to 5G's first huge upgrade. Instead of just one primary key coming from that root, 5G introduces two new, totally distinct anchor keys right at the top of the hierarchy. And this changes everything.
So the very first key derived from your SIM's secret key is something called KUSF. But what's really interesting is what it does. See, K_USF isn't really used for encryption itself. Instead, it's like a cryptographic proof that binds your identity to your home network for that session. Think of it as the ultimate root of trust for your carrier.
Then, from that K_AUSF, the network creates another key, the K_CSAF. And listen, this is the crucial part. The K_CSAF is the anchor key that gets handed over to the network you're currently connected to, the serving network. From this point on, all the keys for accessing that network are going to be derived from this key, not the one your home network is holding on to.
So what you end up with is this really clever separation of powers, right? Your home network, think of them as the ultimate authority, they keep control with the K_AUSF. But the serving network you're actually using right now, whether you're at home or roaming abroad, is only given limited temporary authority through the K_CF. This separation is a massive leap forward for security.
All right, now for the main event. This is where it all comes together. This new foundation with these two anchor keys is what unlocks 5G's most powerful feature, securely slicing up the network.
So, what exactly is network slicing? Honestly, the best way to think about it is like creating multiple, totally independent virtual private networks that are all running on the same hardware. Each slice is its own self-contained world, completely customized for a very specific purpose.
You could have one slice dedicated entirely to a hospital's critical communications, another one for a whole fleet of self-driving cars, a third for all of a city's smart sensors, and, oh yeah, a fourth for just your everyday internet browsing. All separate, all coexisting beautifully.
So how do the keys we talked about make this possible? Okay, this is the real aha moment. That KCSEF, the serving network anchor key, think of it like a master key. From that one key, the network can generate completely separate, unique sets of keys for every single slice your device needs to access. This means the keys for the vehicle network are cryptographically isolated from the keys for the IoT network, which are isolated from the keys for your phone.
And the security payoff here is just huge. Because each slice has its own independent keys. If someone hacks into, say, the less secure smart toaster network, they can't use that to jump over and attack the self-driving car network. No way! The compromise in slice A is completely contained. It doesn't cascade to slice B. That is what we mean by real cryptographic isolation.
But, it's one thing to have a brilliant design on a whiteboard, right? It's a whole other challenge to make it work securely out there in the real world. This powerful plan comes with some pretty big responsibilities.
I mean, the benefits are pretty amazing when you lay them out. You get this incredible isolation between your home and serving networks, you drastically shrink the attack surface for each service, and you get a scalable, future-ready architecture. It's like building with Legos instead of one solid block of concrete, a truly modular fortress.
But here's the catch. A fortress is only as strong as the people guarding it. This whole security promise? It only works if the network operators do their job. They have to configure the slices correctly, secure all the new APIs, manage the keys properly, you name it. The design is powerful, but the implementation is absolutely everything.
So let's just step back and look at the whole picture we've built. It all starts with that unchanging root key on the SIM. From there, we derive the home network anchor, which then gives us the serving network anchor. From that anchor, we create our normal access keys, and then, the final step, we generate unique, isolated keys for each individual slice. It's really an elegant, multi-layered flow of trust.
So, what's the big takeaway from all this? It's that in the world of 5G, security is no longer this flat, one-size-fits-all concept. It's layered, it's modular, and, most importantly, it's contextual. It actually adapts itself to the specific needs and the specific risks of whatever virtual world you happen to be in at that moment.